All right, so in this lesson, we're going to be starting with Unit 6, and Unit 6 is going to go pretty quick. It is not a programming lesson. We'll be looking at some programs and some code, but we're not going to be making any. This is much more of the theoretical, and it's titled Algorithms. So in Lesson 1, we just kind of look at what is an algorithm. So first off, some vocabulary. When we talk about having a problem, this is a task that can or cannot be solved with an algorithm. It's a problem we want to solve. Okay, maybe an algorithm will work, maybe it won't. When we say algorithm, it's a finite set of instructions that accomplish a task. Every time we have written code, it has been an algorithm because it's a finite set of instructions and it does something. So there are a lot of different algorithms that can solve the same problem. And there are many ways to write them or express even just one algorithm. We can use just normal English. We can use pseudocode like the AP exam does. We can draw diagrams. We can actually use formal code like JavaScript. But they're all created by combining steps in 3 ways: sequence, selection, iteration. Sequencing means we just put the steps in order. Do step 1, then step 2, then step 3, then step 4, etc. Selection is where we have some type of Boolean that determines what happens next. So we have an if statement that says, if it's true, do one thing, else do something else. So every time we did a conditional in code in the code lab, in the app lab in code.org, we were doing a selection. And then iterations are when we have loops, when we do something, the same thing over and over and over again. So for loops and while loops are iterations. With problems themselves, so when we discuss problems, there's some more vocabulary. Remember, it may or may not be solved with an algorithm. Some are decision problems like, is there a path? Others are what are called optimization problems, which we will look at later in the unit, such as what's the shortest path. But an example of a problem would be sorting a list. An instance of that problem is sorting a specific list 2, 3, 1, 7. So problems, something that might or might not be solved by an algorithm, which is a finite set of instructions that accomplishes a task. An instance is one example of that problem. So here, there are a bunch of different algorithms. And we kind of want to see which of these do the same as another one. And the easiest way to do this is to either draw it out, or if you have the little arrow from when we were doing the robot problem video earlier in the course, having some sort of figure that allows you to keep track of moving forward, moving right is a great way to do it. What I'd like you to do is pause the video, try each of these algorithms and see which algorithm is like another algorithm here. And then after you're done trying those, and on a piece of scrap, just kind of keep track of which ones you think are doing the same thing, restart the video and see if we match up. Okay, so algorithm 1, if I start facing, whoops, sorry about that. If I start facing up, that says move forward, turn right. Move forward, turn right. Move forward, turn right. Move forward, turn right. So I get a square facing up the way I originally did. If I look at algorithm 2, if I start facing up, I get move forward, turn right, move forward, turn right. And then I'm told to do that twice, so I did that once, so move forward, turn right, move forward, turn right. So I get a rectangle where I end up where I started. Algorithm 3, so I've got FR, 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 FR. So for each move in this list, if it's F, move forward, else turn right. So if I'm starting here, F is first, so I move forward, then R, turn right, move forward, turn right, move forward, turn right, move forward, turn right. So algorithm 1 and algorithm 3 do the same thing. For algorithm 4, I have a counter. If the count is less than 4, move forward, turn right, and add 1 to count. So I'm starting at 0. That's less than 4, so I move forward, turn right. Count is now 1, still less than 4, so I move forward, turn right. Count is 2, so I move forward, turn right. Count is 3, move forward, turn right. Count is 4, which is false, so I stop. So this is also the same as 1. So then if I look at 5, I've got move forward, then turn left, turn left, turn left, which is a turn right, and move forward. So then I do that a second time, move forward, oops, then turn left, turn left, turn left, and move forward. And this is where I stop. So that doesn't look like any of those. For algorithm 6, count starts at 0. If count is less than 2, move forward, and then I have a turn count. So got move forward. If it's less than 3, turn left. So I'm going to do 3 left turns, which is a turn right. And then move forward, turn right. Count is still less than 2. Actually, they don't change count at all anywhere in this. So I'm actually going to get an infinite loop here. So count is still less than 2, so I move forward, turn left 3 times, which is a turn right, move forward, turn right. Count is still 0. Okay, so algorithm 2 is almost the same as algorithm 2, but algorithm 6 goes on forever. So this never stops. It's making that rectangle, but it's making that same rectangle over and over and over again. Algorithm 5 is almost like algorithm 2, but we had 2 move forwards, turn right, move forward. It never turned right again to be able to complete the rectangle the way algorithm 2 did. So 1, 3, and 4 are all the same. 2, 5, and 6 are almost the same, but 5 and 6, 5 has a mistake in that it never turns right. If this final move forward was a turns right, it would be like algorithm 2, and in algorithm 6, it's an infinite loop that never stops tracing that rectangle.